Ever wondered how AI transforms a simple text prompt into a breathtaking painting, or turns a blurry photo into a crisp, detailed image? It all starts with diffusion models, these incredible tools that work by iteratively refining noise into clarity. But here's the problem: they're incredibly slow. Imagine a painter who painstakingly adds each brushstroke one at a time, except this painter is a computer, and every stroke is a complex mathematical operation. Today, we're diving into a groundbreaking advancement that cuts diffusion model inference time in half, without sacrificing image quality. Let's unpack how this works. So why do diffusion models take so long? They operate by gradually removing noise from a random image, like a chef perfecting a recipe through hundreds of tiny adjustments. Each step requires intensive calculations, making them resource-heavy. This is why they struggle to run on devices like smartphones or real-time applications. But what if we could speed them up without compromising quality? That's where PQCAD-DM steps in, a technique that's rewriting the rules of efficiency in AI image generation. PQCAD-DM is like a two-pronged superpower for diffusion models. It combines progressive quantization, PQ, and calibration-assisted distillation, CAD, to achieve lightning-fast results. Let's break these down. First, progressive quantization. Quantization is the process of reducing the precision of numerical data to save computational resources. Think of it as compressing a high-resolution photo into a smaller file. But here's the catch: overcompressing can blur details. PQ solves this by gradually lowering precision, much like a painter learning to use fewer colors while still capturing the essence of a scene. It uses a momentum-based approach to dynamically adjust how many bits, the digital equivalent of colors, the model uses, ensuring it avoids major errors during the process. Then there's calibration-assisted distillation, CAD. This is where the magic really happens. Distillation is a technique where a smaller, faster model, the student, learns from a larger, more accurate one, the teacher. But if the teacher is compressed, the student might inherit its flaws. CAD fixes this by using full precision data during training, like giving the student a detailed textbook instead of a summary. This ensures the student model retains the teacher's accuracy, even with a lighter computational footprint. The result? A model that's half as fast during image generation, but still produces results indistinguishable from the original. Researchers tested PQCAD-DM on datasets like CIFAR-10, a collection of small, diverse images, and celeb face photos, where it outperformed previous methods significantly. Think of it as a race car that's both sleek and powerful, speedy enough for real-time apps, yet precise enough for professional-grade outputs. So what does this mean for the future? Faster AI models open the door to smarter apps, smoother real-time rendering, and more accessible tools for everyone. Imagine running a state-of-the-art image generator on your phone, or using it to analyze medical scans in seconds. This isn't just about speed, it's about democratizing cutting-edge AI, making it practical for everyday use. The next time you see an AI-generated image, remember, breakthroughs like PQCAD-DM are making the impossible not just possible, but fast.